name is Mabrur, and I'm Afridee. Mabrur and I have known each other since high school, and we've been into programming since grade 7 with Q Basic. And our love for programming has only grown since then. Chemistry has always been my least favorite subject, and I always needed help with it. So I thought of developing a program that would help chemistry students all over the world, regardless of which level of education they're on. Whether it's a kid in an elementary school who's just keen on learning about chemistry, or it's a master's student who just needs quick information and calculations at hand. So basically this chemistry suite is built for everyone. So Mabrur and I set out to build this program.
So this program has 4 individual programs within it. So for the first one and for the whole program, I took my time throughout the whole course from February to plan out and execute each section. I completed the first program by the beginning of March and perfected the second program by the middle of March. As you can see here, I used image processing to display an image of the periodic table by using a color map that I found from the MathWorks website. After that, for the second program, I created a structured array. For that, I created a trash file so that whenever I would enter things and delete them from my main code, I'd have somewhere to keep them so that I can bring it back if I may ever need to. So this is my code for creating the field names for the structured array, and this is my structured array. After creating that, I wrote in every single one of these by using Excel, by using that to create the repetition for 1, 2, 3, 4, 5, 6, all the way to 118, which is the number of elements in the periodic table. And with that, we were able to call singular elements and all the information from the periodic table, where I could just write any element's name and it would just display. And for number 1, which is periodic table, I can click it and it will show me the periodic table. For number 3, which is the graph of periodicity, I created a menu system where the user can just select the menu, go to periodicity, and then go to ionization energy to get a graph. For here, I used plot and I used R as a string to create red lines, and the text function to have the elements at the peaks and the troughs. The same goes for electron affinity, where I used green instead. And for the third, I have atomic radius. And those were the first 3 programs. The fourth program will be explained by Afridee.
Alright, as for case 4, we definitely had miscalculated how difficult calculating molar mass with page. Same is, we first input formula using string format, and then we convert it to double so that we can separate letters and characters from it by calculation. So we use a for loop here from I to learn the formula, and then we first consider the first letter to be a capital letter like H. If the first letter is H, it's good. If the second letter is HE, that's another case. If the second letter is a smaller letter, then HE would be considered as 1 element and not 2. However, if you enter HC as 2 different elements, then you'll get the answer for HC separately. So for this, we used another vector here, weight of A, and we input the atomic number of each element here into this vector, weight A. We increment A here so that weight A exists. And after that, this is another for loop to extract the numbers from the string. So we run another for loop from 1 to learn the formula, and then we again consider first letter to be the first space to be a capital letter, and after that the second one is a capital letter too. For example, HC, we automatically consider the coefficient of H to be 1. If that's not the case, suppose we have something, for example H2, we'll get 2. If it's not H2, for example, if it is H23, we will get H23. And that's not the only part. This also works over here. We use another if statement to check if it's for 2-letter element. For example, XE, we get the atomic mass. If it is HE32, we get 32 into HE. So I'm considering HE to be 1 element again, and I'm considering 32 to be 1 number. So as for this if statement here, our first challenge was like, what if someone wants to end a molecular formula with an element, for example HCl. We know that the coefficient of H is 1, but we still don't know the coefficient for Cl. So we use the pre-assigned value 49 here, which will be converted to, and we automatically assign Cl to have coefficient of 1. Anyway, so after all that, we have the vector coefficient, we have the vector weight, and we scalar multiply weight and coefficient to multiply the corresponding atomic number of each element with the number of elements it existed to get molar mass. So that's basically it.